So this is my rock relation diagram. Structural diagram. Again, very simplistic. I'm not expecting a masterpiece. It's just to get a rough idea of what's going on. And so what I've represented here is, well, that quaternary here that represents shaping by the glaciers, like so late quaternary history here. We've got some here. And then we've got this frost fault that seem to all bring rocks from the southwest to the northeast. You can see that in terms of their shape, some of them tend to be fairly linear. The very first one here is much more contorted, and that's what I try to represent here. So you're going to have to think about what that means in terms of the dip of this frost. We also have a series of folds. So we've got some fold axes here. We've got a big one here. So we've got a big syncline here. And the fold axes are sort of parallel to the thrust. So they're quite consistent with a phase of compression, with a compression axis that is oriented southwest, northeast here. And what we have here in terms of the thrust is, so if the thrust are all bringing rocks from the southwest to the northeast, what is the dip of the thrust? The dip of the thrust, they're all gonna dip towards the southwest. And that's what's interesting here, is that if you look at the dip of the beds as well, it's essentially, most of the beds tend to dip towards the southwest as well. You can get that from the dip and dip direction symbols, so there's quite a few on the map. Here, 47 towards the southwest, 47, we've got, I'm pretty sure there's some other ones in this area. But like most of the beds, okay, 27 towards the southwest, 33, 47, 70 here. So quite a range of fairly steeply dipping beds towards the southwest. And that's what I try to represent here, is that the main dip direction is towards the southwest as well. So if you had to draw a schematic cross-section, what we seem to have is a series of thrust dipping towards the southwest. And in between that, we're going to have beds that are dipping also towards the southwest. So that's my very schematic cross-section. Is overall we've got a stacking of units that are dipping towards the southwest. So, and this is how we tend to repeat the succession, is units that are being slivers of these different sedimentary units that are being pushed on top of each other and repeated. That's what allows the repetition of that succession here. There's some minor changes, of course, like you will see there's a syncline here, so there will be places where the dip of the beds is going to change, but overall we'll just have a pile of sediment through which we have thrust that have been running, and these thrusts have pushed them on top of each other. So in terms of calculating the dip and dip direction, there's some nice places where you can do this calculation. And just as a reminder, if you imagine that this is what you have here, imagine that these are the topographic contours. We've got the topographic contours at 6,300, 6,400, 6,500 feet here. And this in blue here is your contact. What you can do, so you should all be confident with that now, is draw the structural contours. So these are the lines along which all the points on the surface that you're considering are at the same elevation. So we know that along that contact, that point is at an elevation of 6,500 feet. This point is at the same elevation. So that line is the structural contour for this contact at 6,500 meters. Similarly, this one is at 6,300 meters, which means that the strike of that contact is going to be parallel to the structural contour. So all the points are at the same elevation along the strike here. And then the deep direction is going to be given here. Well, you're at 6,500 here, 6,300, so you're going down this way, and it's always perpendicular to the strike. So the deep direction in this case will be in that direction. You can go further and calculate the deep angle. So this is, if we say that this is point A and this is point B, if you do a cross section, if now we are looking at a cross section, so we've got the point A here, which is at an elevation of 6,500 feet. We've got the point B here, which is at a elevation of 6,300 feet. We've got alpha is the deep angle here, and this, the tangent of alpha, is the difference in elevation between the 2 points divided by the horizontal distance between A and B. So here, in that case, the difference in elevation is 200 feet. So convert in meters if you want to be able to do the calculations. And then the distance delta x between the horizontal distance between A and B is that distance between A and B on the map. So if you look from above here, A and that distance AB is that horizontal distance. So if you measure that distance on the map, again, using the scale, which is 1/50,000 here, convert that into meters, you've got that distance, you divide that, you can calculate the angle alpha, which is the deep of your surface. So that was just a reminder. You may have to do that in a few places along the line of section, because here, for example, you can use that 47 here, but there are places where there's not that much information close to the line of section, so you may have to do that calculation. Now, what I'd like you to think about is what sort of structure are we dealing with, and what sort of relationship are we having between the thrust and the beds. So are we dealing with something, if I draw the thrust like that, do we have something that is like that? Are they just very steep reverse fault, or are we dealing with a different type of relationship between the beds themselves and the thrust? So think about that angle between the two, and then what you're going to have to do is to start drawing your thrust. So the thrust are, well, the youngest part of the section is the quaternary, so you may want to start drawing your quaternary, so you're going to have a sort of trough of quaternary on that part of the section, and then you're going to draw your thrust, which are the most recent thing, if we ignore the next most recent thing. So draw your thrust. You can calculate the deep and deep direction. Some of them are going to be a bit quite steep. Some are not going to be as steep as the others, but draw them in with a thin line, because you may have to erase them again. And we're going to have to think about the relationship between the thrust and the beds that they dissect.